when I look at the right side, I have an 80 going to the left, 80 going to the right, y is coming out at me, x is going to the left, and z is going up, and it's creating a positive spin about the y. In the top view, I have the 80 coming this way, 80 going that way. I have my x going this way, y going that way. It's creating a spin around the z. Z is coming out at you. It's just going to take practice. How many of you can see it so far? Okay. And some of you, I think, are raising your hand. Maybe you don't see it. So people, you just have to practice. And Evan and I are getting lonely up in the STEM Center. I'm telling you, we're not seeing anybody. Okay, you got to come and see us. Okay. All right, let's do the next. So each of you have to figure out what's the best way. Can you look at it in 3D and see it? Does this help? Putting x and y to get z, does that help? Drawing it in 2D, does that help? And there's got to be at least 10 other strategies. Think of what works for you. Okay, let's do the next one. So now we're looking at the 100. So the 100's going like this, and the 100's going like this. So where are we? Lucas, we're up to you. So what direction is this 100 in?
That would be the y direction.
The y. Can a moment be created about the y?
No.
No, why?
Because they're parallel.
They're parallel. Okay. So the 100 can create a moment about what? Can it create a moment about the x-axis?
Is it intersecting now?
Well, this one intersects, but that one doesn't, right?
Oh yeah, it can.
Right? So it can. So how, let's draw the arrows. So my fingers are going on the top of the box this way, and on the bottom of the box this way. So we have 100, which is in the y direction. Our distance, in order to find the moment in the j, what's our perpendicular distance going to be? 250. I. Is it creating a positive or a negative moment?
Positive.
Try again. Fingers go, you're swimming, you're going around like this, and you're looking at the x-axis. Do your right hand. In order for it to go clockwise, my thumb is pointing into the board, I'm getting a negative x. I could go over every single one of these problems with you if you come see me. Every single one of them. Or Evan can too. Okay, let's do the other one. 100. So Enrique, 100 is in the y. We're looking at the moment created in the z. So the distance has got to be in the x. What's the perpendicular distance in the x?
Which would be 200.
200.
And it'd be negative.
Okay, let's see. We're looking at the moment about the z. Z's up there. It's going like this. It's negative because when I look at the top of the box, it's spinning around like this. It's going clockwise. So it's negative. So what's that come out to be? 2,500 I negative plus 4 zeros k. And again, it's Newton millimeter.
Minus?
Did I make a mistake? Oh, minus, thank you. Minus. Question. Okay, Eric, 75. Let's use a different color now. So the 75 newtons is going down in the back corner. 75. And it's going up in this corner. Does it create a moment about the z?
No,
How come?
because it's parallel.
It's parallel. So 75 times, it's in the z. Let's find the moment about the x-axis, which is right here. What's the perpendicular distance going to be?
Maybe 375.
That's right, 375, because that's the y distance. We're trying to find the spin about the x-axis, if the force is in the z and the moment, sorry, if the force is in the z, then the perpendicular distance has got to be in the y. Is it creating a positive or a negative? If you look at the front of the box is spinning like this, positive or negative?
Positive.
Positive. Okay, then 75 times Maria. So now we're looking at the spin in the y. Again, if the force is in the z, and we're trying to find the spin in the y, the distance has got to be in the x. So we're looking at this, we're looking at trying to find the moment in the y. I'm looking at it from the right side. It's going up this way, down this way. What's the perpendicular distance? The perpendicular distance has to be in the x. 200, great. And I'm looking at the right side. It's going up on the left and down on the right. It's a positive or? Try again. Fingers are going around, it's spinning. It's as if I took this force and I just moved it here. If I moved it here and here, what does that look like? Positive or negative spin about this y? Negative. Hey, does that help? You can move the force. Let me get a, it would be nice if I had another blank one here. So let's do this, you guys. So when I worked with the 100, what I can do when I was trying to find the moment about the x, I could move this guy over. And then you could see it in 2D. And then you could move this guy down to see it in 2D. You could move them over. That might be another strategy. So let's come up with this. What's 75 times 375? Somebody?
28,125.
28,400 and
125.
125 plus. Okay, minus is it 15,000? J, millimeter. So what's the total? Because we're looking at the whole spin that this box is experiencing due to these three couples. So let's add all the i's. Negative 25, so what's that? 3, 1, 2, 5. I. And then the J, 20,000 plus 5,000. J. Plus 10, plus 10,000 K, Newton millimeter. And that's one way to express a moment, right? Radian, how did I express the moment here? What way did I represent this vector? In vector form, right? I represented it in vector form. What's the other way to represent a moment? Magnitude and direction angles. Okay? So let's look at the syllabus. So if we look at page 4 on the syllabus, we just finished couples. We only have one topic left before we have our second exam. We had talked about having the exam when I'm gone, but I'm gone next Tuesday, and we can't